So I will talk about the background of the study. The study of hydrology focuses on the presence, flow and storage of water in the earth system. Hydrologic science includes estimating the amount and quality of water in the various phases and stores, as well as comprehending an underlying physical and stochastic process. Quantifying the impact of this human intervention on the natural system at the watershed, river basin, regional, national, continental, and global scales is another aspect of studying hydrology. The hydrologic cycle is the movement of water from precipitation in the atmosphere that falls to the ground, moves through a river basin or the entire earth systems, and then evaporates back into the atmosphere. We choose the station at Sungai Dungun di Kampung Pasir Raja Dungun, Terengganu to collect data within a year in 2023. This is because the place is located close to the water area and often floods every year. In 2023, this area will have passed the warning level with a height of 39.34 meter. Therefore, we choose this area as our study site so that we could identify the peak flow of the water. Our catchment boundary is around 15.45 km square, which is 1,672 hectares. Next is problem statement. This study aims to collect rainfall data throughout the year 2023 and collect the highest water level data from the rainfall data that has been collected in Sungai Dungun di Kampung Pasir Raja, Dungun, Terengganu to calculate the peak flow using the rational methods and Manning's equation. Problem statement number 2 is to compare the result of rational method and Manning's equation. This is because this research will contribute to the development of flood management strategies, including early warning system, infrastructure planning, and emergency response protocols to reduce the impact of floods on population exposed of floodplains. Objective. The first objective is to determine and plot the unit hydrograph for the proposed catchment. Objective number 2 is to plot the rainfall and discharge data in one graph of the chosen month data. And objective number 3 is to calculate the peak flow using rational methods and Manning equation.
Department of Irrigation and Drainage. In order to guarantee water security and environmental sustainability, the Department of Irrigation and Drainage work to effectively manage the country water resources and encourage optimal land use. Over the course of 8 decades, the department that was first created to supply irrigation facility and develop additional land for the emerging rice farming business has expanded to administer and manage a wide range of water assets. This day, special project eco-friendly drainage, flood control, river basin and coastal zone management and hydrology are all included in the ideal water resource management duty. In this project, we use the website of Department of Irrigation and Drainage at https://www.water.gov.my at flood public info https://publicinfobanjir.water.gov.my to read data of rainfall and water level throughout the year 2023. Hydrograph, meaning hydrological data of rainfall distribution and water level station across the proposed area of Dungun Terengganu were collected and recorded in the form of hydrograph. So if you see in the slide, you can see the graph for March. This is hydrograph of March. And then on this slide, we can see a graph for April. And for the last graph, it show for February month graph. So all the three graph is the highest rainfall data in 2023. Google Earth Pro. Google Earth Pro is a geospatial software that provides an extensive and interactive platform for Earth exploration through an intuitive interface and extensive database of aerial photography, satellite imagery, and geographical data. User can use it to explore the world, enlarge on particular areas to see intricate 3D landscape, structure, and landmark. In addition, the software provides a number of tools for measuring areas, elevation, and distance, allowing experts in disciplines like environmental management, architecture, and urban planning to perform accurate spatial analysis. Case study location. The case study for this project is situated in Sungai Dungun, Terengganu. As you can see, this is the image of Sungai Dungun, Terengganu taken from Google Earth Pro. So the rainfall station we use was located in Kampung Pasir Raja, Terengganu. For this project, Sungai Dungun and Kampung Pasir Raja in Terengganu are the perfect case study location because they regularly receive a lot of rain and flood, especially during the monsoon season. Throughout grasp of the dynamic of tropical hydrology, water management and flood mitigation technique can be obtained through research in this area. Furthermore, Kampung Pasir Raja, which is close to Sungai Dungun, provide a real-world illustration of how flooding affect nearby community and infrastructure, making it a pertinent location for research on the socio-economic impact of climate change and extreme weather. For method of rainfall data analysis, rainfall data is measurement and record of the amount of precipitation that occur over the specific period of time in the specific area. It also refers to the vertical depth of water that may accumulate on a flat surface if all precipitation remain. The mean area rainfall provides an average value that represents the amount of rainfall per unit area, leading to more comprehensive view of the rainfall distribution across a larger area, enabling better understanding of spatial variation in precipitation in this project. In this project, the peak flow within the area is determined by using a rational method and Manning equation. So this two is the rational method and Manning equation. And for rational method is a formula for calculating the maximum discharge of runoff from a catchment above a certain point. This is determined by taking the rainfall intensity in a certain period, runoff coefficient, and drainage area into account for estimating the peak flow rate in the urban area. And for many equation, is widely used empirical formula for estimating the flow rate or discharge in open channels such as river, stream, and channel with a natural or man-made section. While the Manning equation is primarily used for uniform flow condition, it can also be applied to estimate peak flow rate by considering the channel characteristic. The peak flow rate depends on the factor including Manning roughness, coefficient, cross-sectional area, hydraulic radius, and channel slope as shown in the formula. Geographical characteristic. Geographical features are the natural and man-made elements that characterize a specific location and region. These features are the physical quality and component that set one place apart from another and affect its general appearance, climate, ecosystem, as well as the human endeavor. Moreover, the catchment boundary for the station is to indicate how water flow into the designated river and aquatic body for infection water management in suggested area. In addition to analyzing the rainfall and water level station, the closest river cross-section, gradient slope, and terrain profile are examined in order to pinpoint the area distinctive geographical characteristic.
So this is the rainfall data and total daily rainfall data that we collect at Sungai Dungun, Kampung Pasir Raja, Dungun, Terengganu throughout a year 2023. As we can see, the highest rainfall data is occurred in March, which is 1,414. This is the water level data of March 2023 at Sungai Dungun di Kampung Pasir Raja, Dungun, Terengganu.
I'll present the analysis and result. So first, we using the rational method to calculate the peak flow. From the Google Earth, we can know the runoff coefficient is equal to 0.9 and the catchment boundary area is equal to 1,672 hectares. The overland sheet flow path length is equal to 6,160 meter and the slope of overland surface is equal to 3.9%. And we can determine the value of Horton roundness equal to 0.045. Through this data, we can calculate the time on concentration, which is equal to 1.12 hours. We also can calculate the rainfall intensity, which is equal to 179.3 mm per hour. So lastly, we can calculate the peak flow, which is equal to 749.5 meter cube per second. Second, we are using the main equation that can be used to determine the amount of water flow through the river. It connects the slope of the channel to the flow velocity and discharge. So we can using the formula that Q is equal to discharge of water, N is equal to Manning runoff coefficient, A equal to area of cross section, R equal to hydraulic radius, and SO equal to a slope of waterway. So this is our cross section profile of the Sungai Dungun. From the profile, we can get the area is equal to 845 millimeter square. The perimeter is equal to 289 meter. And we can calculate the hydraulic radius, R equal to area per perimeter is equal to 2.92 meter. So we can calculate the peak flow, which is equal to 97,403.87 meter cube per second. Lastly, we are using the hydrograph to predict the flow of water at the outlet of the watershed flowing by rainfall event. From the discharge of water, we can get the best flow and direct flow by using straight line method. Since we have best flow and direct flow, we can calculate the US coordinate, and the unit is equal to meter cube per second per cm runoff. So we plot the graph US coordinate based on time. On 7 March, we can note that the US coordinate is equal to 0, and at March, the US coordinate is equal to 22.961. On 9 March, the US coordinate is equal to 24.17. On 10 March, the US coordinate is equal to 78.25. On 11 March, the US coordinate is equal to 50.76, and the US coordinate on 12 March is equal to 2.47. And lastly, the US coordinate on 13 March is equal to 0.
Okay, for the discussion, the north-east monsoon season in Malaysia occurring from October to March poses significant flood risk, particularly along Peninsular Malaysia coastline. Our research highlight a concerning increase in flood occurrence primarily due to human-induced alteration in the hydrological system, such as rapid urbanization, deforestation, and industrial agriculture. This heightened risk extends to inland areas like Kuala Lumpur, exacerbating vulnerability during intensified rainfall induced by climate change. Our study focused on assessing flood risk within the research area's catchment boundary. Utilizing data from rainfall and water level station over a 31-day period, findings reveal a discrepancy in peak flow value derived from different methods, indicating inundation within the catchment boundary. Proposed mitigation strategy include the implementation of robust flood forecasting system, strategic land use planning, preservation of natural floodplain, investment in urban drainage infrastructure, and regular monitoring to refine flood management technique. And for the conclusion, floods in Malaysia result from a complex interplay of natural and human factors, demanding understanding and proactive measure or study on flood challenges in Sungai Dungai in Kampung Pasir Raja, Terengganu, utilize methodology like the many equation and rational method to assess hydrological responses. Mitigating flood risk in Kampung Pasir Raja require public awareness, preservation of natural water retention future, and sustainable urban planning. Implementing these measures foster resilience and safety for vulnerable community both locally and beyond. And that's all from our